For this tutorial, we are going to be talking about hybridization. Now, I want you to take out the handouts that you were given in class for hybridization, and we're going to work through a few examples from the handout. For this first one, we're going to look at a simple molecule, heptane. The first carbon that we're going to look at here, we see is bonded to one more carbon, and we assume, because they're not shown, that it's bonded to 3 other hydrogens. That means that we have 4 sigma bonds and no pi bonds. So, as you see here, it is an sp3 hybridized carbon. For the second carbon, it's going to be bonded to 2 carbons, and again, we're going to assume that it's bonded to 2 hydrogens because they're not shown, which means that it has 4 sigma bonds and again, no pi bonds. It's an sp3 carbon. Each of these carbons is going to be identical to this carbon, so again, they're going to be sp3 carbons as they're already labeled. Now let's look at this last carbon. I want you to think about it for a second. Now, if we look at it, again, like this first carbon, it's bonded to 1 carbon, and we assume that there are 3 hydrogens here. That means we have 4 sigma bonds and no pi bonds, so it is an sp3 hybridized carbon. Now, for the second molecule, we'll look at the first carbon again, and just like our first molecule, it is going to be sp3 hybridized. The second carbon is going to be again the same as above here, so sp3. Now we have a double bond. So how does the double bond affect our hybridization? Well, in the case of this carbon, it's bonded to 2 carbons here and only 1 hydrogen. We have 3 sigma bonds, and now we've introduced a pi bond here. So that means that this carbon is going to be sp2 hybridized. And this carbon here, again, is going to be bonded to 2 carbons, 1 hydrogen, and it's going to have a pi bond in addition to the 3 sigma bonds, so it will also be sp2 hybridized. And each of these 3 carbons is going to be the same as above, so these will all be sp3 hybridized. Now let's look at the last molecule. For this molecule, our first carbon is also sp3 hybridized just like the first 2. And we have a double bond here, which we know means that we have sp2 carbons here and another sp3 carbon. But what about this oxygen? Well, as we know, an oxygen is going to have 2 lone electron pairs. So how do we treat these lone electron pairs? Well, for hybridization purposes, we're going to treat these 2 lone electron pairs just like they are sigma bonds. So if we're to look at this like a carbon, we have 2 bonds here, 2 sigma bonds, and 2 lone electron pairs, and no pi bonds. So just like these carbons above, it is going to be an sp3 hybridized atom. Now we're going to look at 4 more examples, and the first one that we're going to look at is this one. Now, it's going to have an oxygen here like we looked at before, but now it's double bonded. So how does that affect our hybridization? Well, again, remember that we have 2 lone electron pairs here. So if we treat those lone electron pairs like sigma bonds, and then we have a double bond here, so that's a sigma bond and a pi bond. Now we know if we have 1 pi bond, that tells us this is an sp2 hybridized atom. And then for this carbon here, again, we're going to have 2 sigma bonds and a sigma bond and a pi bond. So again, we are sp2 hybridized. Now let's look at this carbon here. The hybridization of this carbon, we have 3 carbons bonded to it and 1 hydrogen. So again, we know that's 4 bonds, all of them are sigma, so this is an sp3 hybridized carbon. Now for the second molecule, we're going to look at a molecule with 2 double bonds in it. As we've seen before, if a carbon has 1 double bond on it, it is sp2 hybridized. And if we look at each carbon, we see that each of these first 4 carbons has one double bond. So they are all going to be sp2 hybridized. Now, for this third molecule we're going to look at, we want to look at the nitrogen. Like oxygen, nitrogen is going to have lone electrons, but there's only going to be one pair this time. So we see that we have two hydrogens and a lone electron pair and one bond to the carbon here, which gives us a total of 3 sigma bonds and a lone electron pair. So this is sp3 hybridized. Now let's look at this carbon here. Again, we know that if a carbon has one double bond, that means that there is one pi bond, and the rest of these are still all single bonds, just as if they were hydrogens. This is going to be an sp2 hybridized carbon. And we have one more molecule to look at. Let's look at this bromine. How does bromine affect our hybridization? Well, similar to oxygen and nitrogen, bromine has lone electrons. How many? Well, in this case, we actually have 3 lone electron pairs. So with 3 lone electron pairs and 1 sigma bond, we're going to treat this like we have 4 sigma bonds. There's no pi bond, so this is going to be sp3 hybridized. Now what we have over here is a triple bond. This is the first time we've seen a triple bond. So how does a triple bond affect our hybridization? Well, there are only 2 carbons bonded to this carbon here. We have 2 sigma bonds, but now we have 2 pi bonds. With 2 sigma bonds and 2 pi bonds, that tells us that we are sp2 or sp hybridized. And this carbon here, remember, is going to be bonded to a hydrogen, so it will also be sp hybridized. Now, I want you to take the principles that we've talked about here with all of these molecules and apply them to the rest of the molecules on your worksheet.